All right, everyone, welcome to the webinar. Last webinar, we talked about how to maximize cloud usage and cost efficiency using FinOps best practices. And this time we are going to talk about cloud usage optimization tool landscape. It's going to be really exciting. We are going to talk about CloudHealth, Cloudability, and those kind of tools. So thanks for joining. Let me start presenting. Okay. So there you go. Much better. So Madhura, may I ask you to introduce yourself?
Yes, thank you, Dieter. Hey, everybody, I'm Madhura Maskasky, co-founder and head of product at Platform 9.
Okay, awesome. And I'm Dieter Mason. I have been working in the cloud since 2013 at companies like Google, Netflix, Intuit, and most recently Roku. And I'm also one of the Cloud FinOps Ambassadors. Yeah, that's enough about myself. Let's go and start the topics a little bit, right? And Madhura, if there's any questions, please interrupt me. I hope you can see chat in the Q&A section as well.
Will do.
All right. Okay, so the first tool that we are going to talk about is CloudHealth by VMware. And I'm going to walk us through the right-sizing user interface. So in the top left, you guys can see it's EC2 right-sizing by instance. And on the top right, you guys can see that there's about over 700 results, right? So I'm going to first walk you through the user interface, and then we're going to go over pros and cons, right? So firstly, let's look at this highlighted section here. It shows the CPU score. So what is the average CPU utilization? The memory score, what is the maximum memory utilization? Disk, network in and network out score, right? So this is your EC2 virtual machine utilization. Now, CloudHealth takes those scores and converts them into a total score, into a total utilization score, which we see here on the left, right? So that's really great. I like the tabular format of this user interface and the detail that it brings. However, remember, we talked about memory and disk utilization. This will become important later as we go into the pros and cons. Next, we see the instance name. So this is the name that the engineer gave the virtual machine. We also see the API name, which is the type and size of the virtual machine, and the zone in which the virtual machine is running. So this is good information. It is actionable. But keep in mind that it does not show the owner. So not the engineering team, the engineering leadership, the business unit, the cost center, any of this kind of information, and that will become interesting when we go into the pros and cons, right? Next, we see that the savings are being calculated, and they are being sorted by the highest savings on top. So that is how it's supposed to be. However, there will be two specific actions from that we will go into later, right? The first one is that the largest number is about $100. And the second one is that there is likely the need for treating some of these differently than others, right? And we go into detail into how that looks like. And lastly, we have on the very right, we have the action buttons, right? And the action buttons, there's multiple actions that are configurable, and we are going to talk about that in a moment. So this is the entire user interface, right? Now, let's go and look into the pros and cons. What is really going on here? So we still see the user interface on the right. And the pros, of course, are that we have visibility into cost savings opportunities. That's undeniable, right? The optimization recommendations are actionable, right? I can differentiate. I have the most detailed visibility, and I can follow up with actions on those recommendations. Next is that this user interface is going to track opportunities over time, which is also good, right? Is this an opportunity that is 3 months old or 2 weeks old? That makes a difference, right? All these things are useful things, undeniable. I can't disagree with that, right? Now, let's go into the details, and I mentioned some of those before. When we look at the utilization section, we saw memory and disk utilization. When you have a virtual machine, there's usually some software involved, which is called a hypervisor. And this hypervisor can either be a software or it can be hardware. Like, for example, on the AWS side, the newer instance types use the Nitro hypervisor, right? Which is a hardware card that is separate from the CPU. So the software is running on a separate card and not on the actual CPU that is being rented out to AWS customers, right? The hypervisor can see CPU utilization and network in and out. The hypervisor does not have visibility into memory utilization or disk utilization, right? This type of visibility can only be provided if there is an agent installed. So you install your operating system, you install whatever web server you're running, maybe a shopping cart application, and the shopping cart application will become interesting in just a moment here, where and then after that, you need to install helper software, right? Like, for example, this agent that collects that telemetry, the data, about memory utilization and disk utilization, and exposes it to this third-party software as a service SaaS solution, right? If you don't have the agent,
Yeah,
yeah, go
question
ahead.
there, because interesting, you're talking about an agent there. Are you saying that in order for CloudHealth to correctly get your memory and disk information, you need to install a specific agent software that they provide?
That is correct, right? The most common software that is installed is Telegraph, because it works on Windows and then Unix. And it's a very robust piece of software, right? It is open, I believe it is open source, and it is well known in the industry to work properly. But not every agent or every piece of software that you install will work properly. For example, when I worked at Intuit, we had an issue with a sort of like a virus protection software, right? That occasionally it would go into a mode where it consumed 100% of the CPU. And you had to kill the software and restart it again, right? But this agent does not have this problem. However, you do need to install it. Otherwise, CloudHealth does not have that visibility.
And at what level do you install it? At each worker node in your Kubernetes environment,
Absolutely.
for example?
Yes, absolutely. In Kubernetes, you may not need that agent installed because the Kubernetes control plane will expose node and pod. That is what the containers are being called, utilization, right? For CPU and memory. However, if you just run regular virtual machines, right? Yes, you need to install that agent, and it will be another piece of software that is installed on your operating system, let's say like the calculator application on Windows, as an example.
I see.
Okay, cool. So moving on, I mentioned that there were over 700 results. This screenshot shows about 9, the last time I counted. It will not scale, right? That is the problem. What if you have several thousand results, right? What if you're spending 50 million annually or 100 million annually on the cloud, right? And you have several thousand of those results. Yes, there's a download button. I can download this information as a CSV file and then manage it in Excel, but that just means that this user interface is not sufficient, right? The other thing here to mention that I said before, while it does, the user interface does expose actionable insights with the instance name, the instance type, and the region, it does not show the owner, right? It does not show who the engineer is, who the engineer reports to, what business unit this is, because the cloud provider has none of this information, right? The cloud provider just has accounts, projects on GCP, and subscriptions and resource groups on Azure, right? The cloud provider knows nothing about your HR structure like Workday or something like this, right? So when you have something like these types of recommendations, you always have to track down the owner to make sure that the recommendation is acted upon. Next is, let's take a look at this action button, right? What are the different things this action button can do? For one thing, it may just execute the right sizing recommendation, right? So we are going back to, we have some operating system running, like maybe Linux. We have a web server running on this, right? Like Node.js or something like that. And we have a shopping cart application, which is our own software that we produced, right? And now if you just execute this right sizing recommendation in a production environment, very likely what this will do is it will shut down the servers and restart it on a right-sized virtual machine type, right? This means that in the meantime, between the shutdown and the restart, the service will simply be unavailable, right? If this is a shopping cart application, you may lose transactions that are in flight, and it will cause many other problems, right? And that is assuming that there's no manual configuration required after the restart, right? If an engineer needs to go and set a couple of parameters, then the service will be unresponsive until that action is being performed, right? So let's keep this in mind. Another downside here is that typically, let's say you have this shopping cart application, you will run some tests on it, like smoke tests or load tests or something like that, right? For Black Friday, Cyber Monday, something like that. Does this service sustain the load of such an event, right? And that testing is also not being performed by this application. So even if you are able to execute this right sizing recommendations in the production environment, it is very likely not a effective way of doing so, right? Now, what is another thing that you can do here is you could maybe open a Jira ticket and assign it to an engineer, right? So you have some ticketing system, whatever it is using internally, and you have to now identify who this engineer is, right? And open a ticket of the type of the queue that this engineer is working on, right? So the ticket queues, every team will have its own queue, or maybe you have a subcomponent in a general ticket where you have to specify the team and to be able to assign it to a specific engineer, right? I mentioned earlier that the largest on top dollar value on top, right, was about $100, $108, right? When you open tickets, please do not forget that tickets have a cost, right? They are not free. There is some time investment on the engineer's part to look at that right sizing recommendation, maybe run this load test, run at least a smoke test, right? And then execute that right sizing recommendation in a safe way. The way to do that is you leave the old web server running, you start up the new instance with the new web server, and then you take the IP address and you point it over to the new server, and then you take down the old server, right? So the engineer has to follow a certain protocol in a production environment to be able to do that safely without customer impact. When I work, yeah, go ahead.
Yeah, just interjecting here. I think that's an interesting point. I think you're saying there's a cost with the Jira ticket, and it's really the engineering hour cost, right? Which is
Exactly.
software development. Other resources are expensive resources for an organization, and the time that engineers have to spend fixing these tickets amounts to a non-trivial cost to an organization.
That is absolutely right. Yeah, at Roku, that minimum cost is $2,000, right?
Wow.
If something is under $2,000, I can't do anything about it. I need some other type of automation that takes care of that, right? I work with many other clients as well, and another client told me that their average cost for a Jira ticket is $17,000. Now, that means that some Jira tickets will have maybe weeks or months of effort, right? While other Jira tickets will maybe just be, a few hours of effort. This might be
Right.
one of them, but overall, the average Jira cost is $17,000. So at that organization, if I were to open a Jira ticket for something that is less than 17,000, I would be basically wasting money.
That's massive. I think 17,000 is definitely non-trivial for any organization to consider in terms
Absolutely.
of, right?
Yeah.
I think to mention, I guess, in terms of just added information specifically on this right sizing topic. Kubernetes has made it possible, starting I think version 129 or so, to auto right size request limit values for containers without requiring restart. So I think over time, these applications like CloudHealth and others would probably bring that capability in as well. So the downtime may not be required as it is today. However, there's also the other side where downtime or not, engineers may not be willing to accept a right sizing recommendation because engineers have spent a significant amount of time setting or configuring the request and limit values for their containers for both CPU and memory after doing a level of experimentation and accounting for what it would take to not have the application terminated because it ran out of memory or for it to get CPU throttled, right? So there is a level of resistance in even incorporating these recommendations, and it's definitely not a decision that the DevOps teams can make on their own.
Yes, and that actually brings me back. I used to have a slide in this deck, but we removed it, where we talked about the human aspect of this, right? Does the engineer have the knowledge to act on this, right? Any recommendation that I put in front of an engineer, if they don't know what to do, they can't do anything about it, right? So training may be required. Does the engineer have the motivation to act upon it, right? Maybe the engineer is fully booked. They are writing code, for the next 9 months. There is a sprint schedule that they need to follow, and they're extremely busy. They don't have time for distractions, right? So unless you make this part of their objectives and key results of their performance review, right, the engineer may not see a motivation to act upon these because, the money does not go out of their wallet. It goes out of the organization's wallet, right, or bank account. So, and lastly, leadership may not give time to the engineers to work on this, right? Leadership may simply say like, no, you're not allowed to do that. You need to work on your features. You need to work on new features, upgrades of existing features, that kind of stuff, right? So in that case, you need to work with leadership and with executives to explain that, cloud waste is a real thing. We are seeing between 25 and 30% average cloud waste. So if you're spending $100 million annually, I wouldn't be surprised at when I worked at Intuit, our first snapshot of cloud waste was 25%, and we used 6 waste sensors. Those are little scripts that find orphaned resources or underutilized resources or not resources not utilized at all, right? And we built a dashboard very similar to this one here, except that ours had the HR structure, the Workday reporting structure in it, so that we were able to put names to those recommendations, right? And that, by the way, that effect, once you start putting names there, we get to the last item, the exemptions, right? The first thing that someone will say like, hey, I don't want my name on this dashboard anymore, right? They are looking at this dashboard like once a week, once a quarter or something like that. My name is always on the top. I don't want my name to show up there anymore, right? It's an understandable human desire, right? And maybe the argument is, listen, this is a legacy SaaS license that we are running on Windows. It does not have the ability to auto-scale, right? We deliberately over-provisioned it so that it can handle those usage spikes, right? And we are planning to migrate off this within an 18-month time period, right? So now, once you start getting into this area of granting those exceptions, right, those exemptions from the dashboard, so where basically you're not showing the ones that have requested exemptions, right? There's a couple of other things that you need to start doing. For one is you need to have another dashboard that just shows the exceptions, because you want these to be reviewed at least on a quarterly, maybe on a monthly basis, to make sure that the owners of those exceptions are still on track with whatever they need to do, like migrate off of this, right? The next one is you maybe need approval structures in there as well, right? Because there is usually thousands of engineers and only one FinOps guy like me, right? So I want these things to be self-service. If I make this self-service, any engineer could ask for an exception. So I need to figure out who that engineer's manager is to approve that exception. And let's say a director or a vice president asks for that exception, I need to figure out who their manager is to approve that exception, right? To make sure that there was a little bit oversight on it, and we are not just generating exceptions, without any controls, right? You need some guardrails there, and the approval can help with that greatly, right? So those are all things that once we started using dashboards like this, and CloudHealth is one of the better examples. We have many others that we are going to go over. Those are all the shortcomings or the cons of these types of tools. Okay, let's look at the next one. So here we have something that is visually very exciting. It's actually the right-sizing dashboard by Cloudability, which is owned by Matzion now. And I'm going to walk us through this step by step, how this looks like. By the way, this type of visualization is called a river flow diagram, a river flow diagram. All right, let's look at on the very left, we see that this starts with Amazon, Azure, and GCP. So this solution supports all three clouds. That's great. And Azure is by far the largest component there with 183,000, right? Next, we look at what are the services that are impacted. We see here that the majority of services is disk, compute on the Azure side, and then EC2 and SQL also on the Azure side, and EC2 on the AWS side, right? So we get a breakdown of services, which is good, right? Next, we get what are the actions that are recommended by this engine here, right? And on the top left, we see that the total optimization is 201,000, right? So now in this box here in the middle, we see the breakdown of those. There are about 150,000 in right-sizing recommendations, 124,000 in just, this is no longer needed, you can safely terminate it, and a small portion in auto-scaling. So it's statically provisioned, and this recommendation recommends that you should be auto-scaling that instead of having it statically provisioned. Next, we see a breakdown of regions, which is great. And then we see a breakdown of the actual activities that need to be performed. So we see like Aurora, MySQL, Windows, bring your own license, SQL databases, and those kind of things. If we can tell one thing of this diagram is that the right-sizing challenge is quite complex, right? This river flow diagram illustrates that very well, that we have multiple actions that need to be performed. We have a slew of services that are affected by different types of actions, and this is spread around the globe pretty well, right? So it is quite a complex situation to tackle. And I think this diagram shows that quite well. Now let's look at a couple of other things here. We have CloudZero, which is another popular tool. And here's the user interface. And again, I'm going to walk us through this. For one thing here in the highlighted section, we see that there is resources that are being shown. You can also show regions. Now we see that it does it by cloud provider. So unlike Cloudability from before, CloudZero shows a view that is provider specific. This can be good. This can be a detriment as well, right? Because once you switch from AWS to, let's say, Azure, you lose the visibility into what happened on the AWS side, right? So you can't look at this holistically. And it also seems to provide these recommendations that are service specific. So unlike Aptio, where we saw everything together, right, in one view, here we have a very service specific view. But we see here that we have the names of the resources. Let's see, what else do we have? And we have, of course, I assume this is the potential savings, right? Again, this dashboard has the same drawbacks as the very first one by CloudHealth, right? That it doesn't scale very well. In this case, it appears that you don't have the ability to perform any actions. This is informational only, right? And what all of these tools have a problem with is finding the engineering owner, finding the business owner, attributing this to a business unit, to a cost center, those kind of things, right? At least in this case, there is some breakdowns of what the performance is, how old this recommendation is, and those kind of things. We will see this in other tools as well.
Dieter, one thing I'm wondering about is, and I think essentially CloudHealth and Cloudability from Aptio, which is I think now part of IBM, those are some of the popular large-scale tools, right? And then CloudZero, relatively new entrant, still been around for a few years. What are some of the distinct differences between a tool like CloudZero versus some of these larger tools like CloudHealth or Cloudability?
That is a very good question. Personally, I'm not aware of it. To me, it always feels that these tools are in catch-up mode. But one thing that they can do to overcome this catch-up mode is to provide one specific functionality that no one else has. And this could be, for example, anomaly detection. Utascale is such a tool, right? This could be forecasting of cloud spend, right? This could be having a waste dashboard that is personalized, where it integrates with, let's say, Workday or whatever other HR tool you're using, right? And it finds the engineering leader. It has some spin that no one else, some capability that no one else has, and that gives it an advantage over other tools that are lacking that. But for the most part, it feels to me that these tools are mostly in catch-up mode, right? They try to be as good as the others.
I see. Are they less expensive compared to some of these larger tools then?
Yeah, very likely. I mean, I have been a spokesperson for CloudHealth for 4 years, and it's a massive organization, right? They have a lot of staff, and they have a training business unit, right? That all they do is provide in-person training. There's also on-demand training that is virtual or online, right? And their training curriculum is extensive. CloudHealth has a lot of capabilities, right? The dashboard that we saw earlier was for virtual machines. It has a different dashboards for Kubernetes, right? And many times these functionalities get added through acquisitions, right? That a large organization is looking to fill a gap in their product portfolio, and they do a very targeted acquisition of someone that does this very well, and to bring this capability into their fold.
I see. Yep, makes sense.
Okay, let's move on to FinOut, the Costguard tool. So we see here, I mean, from a look and feel, it looks modern, right? It almost looks like it might work on a phone or a tablet, so that's great. Let's walk through the individual components here. So we have the total savings of 603,000. That's great. And then to the right, we see the breakdown of like right sizing, commitments, and idle instances. First thing that I notice is that the numbers on the right don't add up to 600. So there is probably other categories that are currently not being displayed. Then we see here in the highlighted section, there's the potential savings, a donut chart breakdown, with Amazon EC2 being the vast majority in green. Then we see DynamoDB has a sizable portion, Amazon S3, and whatever the yellow is, I can't make that out, right? And then you have here in the main section a very high level view, right? You have the Amazon EC2 breakdown now with a number. This information is duplicated from the left, right? That's the green part of the chart, I assume, right? So we already have this information. Now we have it in a tabular form next to it. And then, you get this breakdown of DynamoDB, Amazon S3, and RDS. That was the green one, the yellow one that I wasn't able to see, right? And now what is interesting here is you see the dollar value and trending. Is it going up or down, right? And then you see the identified resources. So there's almost 500 of these resources that make up 120,000. So if you make 120,000 divided by 500, you get the average right sizing opportunity, which is relatively small in this case, right? And here on the very right, we have again the savings, the projected savings, right? So here the projected savings are 330,000, which is interesting. I guess those are the savings that the tool already accomplished. So not super sure how to read this, but you guys get an idea of how these tools work, right? In the top right, you can choose a time duration. Currently, last week is selected. And while we do have cost center as a group by cost center, I don't really see the name of the cost center. So I'm not super sure how this all fits together. But it's a more modern look and feel. Some of the duplication is some of the data is being duplicated. Some of the data doesn't quite add up, and that is a common thing that I see across the industry, where one of the first things that I ask my clients that are looking for my advice is make sure that your dollar numbers are accurate, right? You want people to trust in your solution, and not having accurate dollar numbers will erode this trust. And accurate dollar numbers means that you need to calculate the effects of enterprise discounts, of private pricing agreements, of private rate cards that are service specific, of savings plans, of reserved instances, or committed usage discounts and reservations on GCP and Azure, right? The dollar numbers have to make sense. If I show this to a finance person, the first thing that they will ask is, why does none of these things add up? Okay, let's look at the next one. Trusted advisor. That's my favorite. The community is quite divided. I think the people new to FinOps, they like trusted advisor, while the more senior people know of its shortcomings. One of the first things that we see, do I have something here? Yeah, I have the walkthrough. So we have the different types of recommendations, and you see this in the highlighted section, right? So that's great. And we see that these recommendations are not cost specific. You get all types of recommendations, security recommendations, fault tolerance, and also cost optimization. So the recommendations, let's say the third one from the bottom, is a cost optimization recommendation that is 166 days old, right? So it hasn't been acted on for about half a year. Again, this is the tabular nature of this user interface is great, but it doesn't give me ownership, right? This one doesn't even give me a dollar value, even though AWS would be in a fantastic position to accurately calculate the dollar value of these opportunities.
I think one question I have, Peter, is this a paid tool from AWS or is it part of their free offering?
Oh, that's a good question. No, it's part of the free offering, right? As I believe enterprise customers get this for free, right? So if you are spending, I believe 10, 15 million plus annually, this is part of your support plan, and you get Trusted Advisor for free. There's a couple other tools that AWS has. Another one that is free is the cost anomaly detection. Is, I believe, completely free, and it's quite accurate, right? It will even find outliers that are just a couple of dollars. So it's not like a, hard-coded percentage or something like that.
I see. Is this one of the tools AWS recommends? I know that
Absolutely.
when customers come to AWS with their cost management pain points, there's a few tools they recommend. Can you talk a little bit about that, Peter?
Yeah, I mean, this is their default go-to that AWS recommends. Use Trusted Advisor, right? And this is why I mentioned in the beginning that the more junior people, they will say like, hey, this is a spreadsheet style tabular format that gives me all the different opportunities, all the different recommendations. This is very great. And then the more senior people, the first thing that they will say is, well, what is the dollar value of the cost optimization, right? Because I can't ask my engineers to work on something that's less than $2,000. Which engineer should I talk to, right? There is this underutilized EBS volumes, search and recommendations. Okay, great. Maybe I can go and talk to that director, but it would be much more useful to find the actual engineer that is responsible for that, right? So there is the usual shortcomings here that this doesn't scale. What if you have several hundred or several thousand of those line items, right? I mean, we see here we have only 38 items, right? Because this is in a test account. So I actually took the screenshot myself, and it's just not usable at scale. That's the problem.
Makes sense.
Okay, let's look at the next one. So, Madhura, you actually asked me to show some screenshots of Karpenter. I wasn't able to find any because that's actually the fifth item from the top. Cluster performance dashboards don't exist. So, step one, right? Karpenter is a great tool for Kubernetes, mind you. It is an open source cluster autoscaler that automatically provisions new nodes in response to unschedulable pods, right? So you have containers. The containers are running on virtual machines. And if the control plane realizes that it cannot instantiate additional pods or containers, it needs to instantiate a new virtual machine to have room for these new resources, right? And that is what Karpenter is doing. It does EKS cluster scaling very well, so green check mark. It uses the AWS APIs, so great. It supports AWS Spot instances. So there's two types of compute on AWS. There is regular EC2, and then there is Amazon Spot. And Spot is preemptible compute. You get like a 2-minute warning, and then Amazon at any given time can take that virtual machine away from you, right? So you have EC2 and Spot. Spot is preemptible. EC2 is forever unless there's a maintenance notification or something like that, right? And so Karpenter can use both products. So great, that's fantastic. It does node right sizing. Remember, the node is the virtual machine, not the pod, right? Not the container running on the node. It does the node right sizing. So that's great. Now, a bunch of things that it doesn't do very well. It doesn't have dashboards, right? It doesn't do the actual pod right sizing. It doesn't select a virtual machine type that lends itself to the requirements of a workload. So let's say that a workload has very specific requirements. The Karpenter is agnostic to that and just puts the container on any virtual machine. It doesn't optimize the VM shape to the workloads. It doesn't do continuous configuration tuning. What is that? That is that it observes, let's say, over time, the parameters of the horizontal autoscaler or the requested memory, the requested CPU, right? And it observes those over time, and it continuously tunes these configuration parameters to run optimally. Karpenter is also not aware of reserved instances or savings plans, right? So these are prepayment products. Think of it like coupons, right? You get like 20% off an Applebee or something like that, right? Or a 10% off Mountain Mike pizza, right? The coupons are very specific to VM types and sizes, or at least they can be. And Karpenter is simply not aware, is there a VM shape out there that has this RI coverage, and which makes it cheaper than a VM shape that does not have that RI coverage? So very important that it has that awareness, right? And unfortunately it doesn't. It also is not able to adjust convertible RIs based on the workload demand. So what is a convertible RI? Think of it as a coupon, a digital coupon that you can trade in. So I have an Applebee's coupon, and I trade it in for a Carl's Jr. coupon, right? And I can do that on the fly using an API. And the way to do that is, if I now know that my workloads, maybe they transition from online processing to batch processing because it's 6 p.m., right? And the type of the workload changes, so I can actually use different VM shapes, and I could adjust those convertible reserved instances to follow those VM shapes. It cannot do that. And lastly, another thing that it is not able to do is predict determination of a spot instance. Yes, Amazon gives you a 2-minute warning, but that is an absolute warning. That means after 2 minutes, that VM is gone. You're going to be evicted, right? What you could do is build, because all this information is publicly available through APIs. So you could constantly query the AWS APIs to get information of how likely certain VM sizes and types are going to be evicted based on short-term trending, right? And Karpenter does not have that ability as well. And that leads me to the Elastic Machine Pool, Madhura. We have short of 15 minutes, so I don't know if you want to take over or how you want to proceed.
Thank you, Dieter. If you could help proceed the slides for me.
Yep.
Great. So I think that's great context and background detail for diving into Elastic Machine Pools. And just as a introduction to everyone, Elastic Machine Pools, or EMP, is a new product built by Platform 9. We've been working on it for almost a year and a half, and the product is in limited availability, limited GA right now, looking to go fully generally available in about 1.5 month to 2 month time period. And EMP is a product that's focused specifically on cloud cost optimization when running Kubernetes in the public cloud, starting with EKS as the first supported Kubernetes, cloud-native Kubernetes offering. The biggest difference between EMP and a number of tools that you mentioned, Dieter, across CloudHealth and Cloudability, which are more, and CloudZero, which are more visibility tools that really give you that list of instances to optimize, along with some right-sizing optimizations, to then tools like Karpenter that actually go and execute things like finding the perfect instance sizes for your pod placement, etc. EMP takes a very, very different and unique approach towards how it helps save on the EKS costs, right? So we kind of map the spectrum of cloud cost optimization tools to be following roughly in these 4 buckets. starting with visibility, which is where CloudHealth, Cloudability, CloudZero, KubeCost, those tools lie. Then there are financial optimization tools like NetApp Spot that let you make intelligent use of Spot instances to save costs, or reserved instances or savings plans. Then there are tools that go one step further on top of visibility and actually execute on some of these recommendations. Cloudability, CloudHealth also do to some extent. Karpenter primarily does that. Karpenter may not do right sizing of your pod request and limit values, but it'll find the right sized instance to avoid the bin packing wastage. But what we find is that none of the tools in the ecosystem today truly attack the underutilized request and limit values in a sort of fully automated behind the scenes manner that does not require changes to your request and limit configurations. That's really the approach that EMP takes. And so let's dive into exactly how EMP solves this problem. So let's go next. And the reason why we decided to build EMP again, despite there being so many tools around Kubernetes cost optimization that are there today and have been there for a while, is we found that despite there being all of these tools, Kubernetes utilization still stands at a very anemic value of at the most 30%, right? Most companies have their clusters standing somewhere between 15 to 20% average utilization. And especially in the public cloud, it means about 70+% of your expensive resources are going waste. And so we felt that there's definitely a problem here to be solved. Let's go next. And this is just another statistics from Datadog that we like to reference, which says about 45% of the containers use less than 30% of their requested memory, which is really goes to the heart of the problem, which talks about the fact that it's really these requested resources that are not getting utilized. That's kind of the core of the problem, and tools like Karpenter can't fix that particular issue. So let's go next. And Dieter, we spoke about this, any tool that might either perform auto resizing of your request or limit values or give you recommendations around changing the request and limit values will typically get a lot of resistance from developers, because developers are measured by the application SLA. If there is a company-wide outage that impacts all of customers or even a portion of the customers, it's the developers who are responsible for that app SLA that get held accountable for that outage. And so they are developers watch the request and limit values for their applications very closely. And because there is a potential for application downtime, there is a tendency to set these request and limit request values at least to be in a very pessimistic way, meaning let me set the request value to be what my app requires at peak time, not necessarily what it requires on average, which results in a lot of wastage of resources. So let's go next. And so EMP takes a dramatically different approach compared to any tool that's out there towards saving your EKS or your Kubernetes costs, right? And I want to reiterate, the approach that EMP takes is unlike any other in the industry today, where EMP utilizes or leverages AWS bare metal in a very unique and powerful way. So instead of you deploying a fleet of EC2 worker nodes as workers for your EKS cluster, with EMP, EMP deploys on your behalf a pool or a fleet of AWS bare metal nodes behind the scenes. And then on top of that, it deploys its own virtualization using open source KVM, and we create a fleet of virtual machines, an alternate virtualization layer, which we call elastic VMs. And these EVMs or elastic VMs look and feel exactly like your EC2 worker nodes, except they're highly optimized and highly aware of your actual utilization of resources. So let's go next. So what EMP does is, again, the big differentiation is that EMP is utilization aware, meaning your app may be configured with 10 GB memory for request value, but if it's only consuming 1 GB currently, EMP is only going to try to give it 1 GB or maybe 2 GB. And that's kind of the key way in which EMP saves costs, because it's very utilization aware And it does that by leveraging a feature called over-provisioning of resources, which is, again, being used in virtualization and private clouds for decades, that relies on the fact around statistical multiplexing that not all virtual machines consume all the resources they're configured with over their lifetime. And so with EMP, you can typically configure about, say, 2x to 2.5x to 1.5x memory over provisioning, for example, and similarly for CPU. So you can really cater it based on your application requirements and application performance. And so you can see in this example, even though the individual worker nodes, blue indicates the actual utilized capacity and pink indicates unused capacity. And so the individual virtual machines that are your worker nodes for your EKS clusters may not be fully utilizing the capacity given to them. The underlying bare metal, which is what you'd be paying for with EMP, actually is getting utilized a lot more. And that's how you derive the best value out of the resources you're deploying with EMP. So let's go next. And so the question that arises with that is, well, what if all of a sudden all of the VMs you've placed on, say, a bare metal node start consuming all of the capacity given to them? What would happen to them? Would they experience throttling or out-of-memory errors? And the answer is no, which is another distinctly unique capability of EMP, which directly correlates to your app SLA, which is when EMP detects such contention, when, let's say, all of the VMs on a particular bare metal node suddenly start consuming all of the given resources, EMP has ability to live migrate some of those virtual machines seamlessly and behind the scenes to another bare metal node, which would have more resources. So in this example, EMP live migrated node C from the bare metal 1 to bare metal 2 because it detected contention at bare metal 1. And when I say live migrate, I mean live migrate, right? This means, and we have a demo that we show, it's also available on our website. Your apps would be running on this node C, on this worker node. You would have this pod C running in this case, and the pod will experience absolutely no downtime. It would continue to run as the worker node behind the scenes is getting migrated to bare metal 2. So no restarting of pods, no rescheduling of pods, no kind of restart of any form required. So in this way, EMP is able to retain the availability even better than almost all of the right-sizing tools that exist in the market today, because all of the tools that exist in the market require a restart. Mm-hmm. So that's kind of, in a nutshell, the core value proposition of EMP. If you go next, Dieter. Mm-hmm. Why, again, reiterating the zero-part disruption point, and especially we've noticed with a lot of enterprises we work with that for Java applications or even for AI tools or applications, they can't tolerate downtime. So being able to live migrate content or pods around, to achieve better defragmentation of capacity ends up becoming very critical. And EMP is the only tool that's able to achieve that. And so let's go next. And so I think without being too aggressive with the over-provisioning settings, what we find in reality is that EMP is able to achieve significant cost savings, right? So here's an example of a before EMP environment with, let's say, an annual cost of about 100K or so, deployed using M5.4x large instances on EC2 with a single EKS cluster. And this is based on the on-demand price for those M5.4x large instances. With EMP, same cluster config, exact same instance type, M5.4x large, just provisioned using EVMs rather than the regular EC2 VMs, with, let's say, about 2 to 2.5x memory over provisioning, the annual cost goes down to about 41K. So more than 50% savings, right? About 60% savings using EMP. So in a nutshell, EMP is able to get dramatic savings while not being too aggressive with the over-provisioning policies and without impacting your application SLA. So let's go next. So yeah, it's one of our design partners, an example that we like to mention, where we were able to achieve about 8 million or so in cost savings for them, about 60% reduction, because we were able to pull their resource utilization from about 17% or so, memory was the bottleneck in their case, to upwards of 40+%. And so that's really the potential with EMP. So I think that's essentially the gist of it, right? In a summary, EMP takes a fundamentally differentiated approach compared to any other tool that is out there in the marketplace. And as a result, you can achieve more than 50% savings with EMP without any application downtime. So for heavy applications that can't tolerate pod disruptions, AI applications, etc., EMP is a very good fit.
Hey, does anyone have questions who is attending? You can either put them into chat or into the Q&A section. We are going to monitor both. So maybe just in summary, right? We have seen a whole bunch of tools, right? And we have seen the pros and cons of them, right? That they don't really scale, that there's hundreds of actions, that I need to find the engineers, the business owners, right? That even creating exceptions for them opens a whole nother, bag of issues. There's just a lot of manual steps that are required, right? And so, which makes EMP so unique, because it does that all behind the scenes for you, right? And for me, the most impressive technology is the automated bin packing, right? That I can specify by how much I can over provision, right? And that a pod can migrate to another virtual machine. What is the technology used for that, Madhura, for the live migration of pods?
It's an equivalent of a vMotion, and I think that's that tech. And we have, for those interested, I recommend going to the Platform Line Docs website, EMP Docs, and we have articles that talk about the live migration and its potential performance impact. Essentially, what happens is, behind the scenes, we would be copying memory blocks of the VM from one host to the other while the VM is still running, right? All except for the dirtied memory gets copied. Then the actively dirtied memory gets copied while the VM might experience sort of a momentary freeze, microseconds to milliseconds. So your app may not even detect that there is a freeze. And then the VM gets resumed on the new destination host. And a lot of state has to be copied over, right? Not just the memory, IP addresses, your storage volume state, any networking context, all of that essentially gets transitioned over to the from the source host to the destination host. And you can find more information about it on our webpage. I think if you go to platform9.com and go to products and EMP, you will find a lot of information, detailed demo video, which actually shows some of these components, data, live migration, etc., in action, and read the docs as well.
We have a question here by Chintu, who I hope I pronounced the name correctly, and thanks for asking. But how does EMP compare to other such solutions? I think so. We are using a horizontal autoscaler, which is Ocean by NetApp, right? By Spot by NetApp, and we are using a vertical autoscaler, which is ScaleOps. It's a small startup, right? And that is, it needs a lot of configuration, right? Every little thing has to be configured. Like, what is the overhead that a worker node needs to have to accommodate, pod growth? There's like a gazillion of parameters that need to be specified, right? You need visibility into data transfer charges on a pod level, right? This EMP solution makes all of this completely unnecessary, right? You just run your pods and you don't need to worry about anything. The system itself takes care of it.
Fantastic. Thank you, Dieter.
Yeah. I think we are at time, actually. Exactly an hour. I'm surprised. We got it done, Madhura. Thanks so much.
Thank you, Dieter.
Okay.